Welcome to this lecture. In the last lecture, we had discussed about the transform analysis. Next, we will discuss about transaction analysis and also when to apply transform analysis and when to apply transaction analysis. But before we do that, we will just take one more example to see how the transform analysis is applicable, because the last example that we saw, that is the root mean square computation, is a very simple trivial example. We will take slightly more non trivial example and see how transform analysis can be applied. So, let us look at the tic-tac-toe computer game. We had developed the DFD representation of the tic-tac-toe computer game. We had seen the problem statement earlier, that the human player and the computer alternatively make moves, and once there is a decision, one player wins by marking on consecutive boxes in a row or a column or on the diagonal. A winner message should be displayed, but if no one gets that and all the board elements are filled up, then the game is drawn and a message that the game is drawn is displayed. The context level, we had drawn this diagram for the tic-tac-toe software. The human player gives moves to the software and it checks whether the human wins, then it will display a win message congratulating the human player. Otherwise, it makes its own move, checks if it moves, its move makes it winner, then it will display the corresponding message, or it just displays the updated board and prompts the human player to make the move. In the level 1 DFD, we had seen that the move is read and it is validated, and then the board data structure is updated. The board data structure is a array of 9 elements that we had discussed, and based on the input, the check winner is executed, and if there is a result, if there is a winner, it is displayed. Otherwise, the computer makes its move and finally, the board is displayed. So, how do we do the transform analysis of this? We see that this is the input part. It takes the input and converts physical data into logical form, and this is the output part. It displays, and the rest are the processing part. And even though this bubble here, it produces some output, but then we observe that its primary role is processing. As a byproduct of the processing, it just displays some result, and its task is not to convert logical data into physical form. Its main work is to do processing, and based on that we had classified, or we have made this into the processing part. And once we have done that, we can easily draw the module structure. So, this is the module structure: get, good, move, compute, game and display. And observe here that these are factored, because we had get move and validate move are two work that is done by the get good move. Similarly, compute game consists of two different activities, play move and check winner. If you observe the DFD, see that these two are present, but it is not really necessary that each bubble that is mapped onto a module here becomes a sub module here. Now, let us look at transaction analysis, but before we look at the transaction analysis, let us see a general idea when to apply transform analysis and where to apply transaction analysis. In transform analysis, normally the DFD, whatever data is input into the DFD, if this is our DFD, let us say this is our DFD, whatever data is input, they are all use some similar processing and finally produce the output. The data D1, if it is input here, undergoes similar processing, and typically it takes just one data, but it is possible that it may take multiple data items and they undergo similar processing. That is, it is processed here and then next processed here and so on. Whereas, in a transaction system, some data are processed by these ones. So, this is one transaction and another data may be processed through a different transaction, different bubble. So, each of these will become a transaction. So, the D1 data is processed through these bubbles and D2 through these bubbles. So, they are two different transactions. Typically, when there are menu options, depending on the menu option chosen, some functions are executed. For example, if you want to, let us say, a drawing package, you want to do editing, some specific functions will be invoked. If you want to do printing, some other functions will be drawn, they will be executed. If you want to do save, some other functions will be executed. So, typically the data that is input by to a DFD, they are processed in by different functions, and each of those functions we call as a transaction, and we can represent this in the form of a structure chart. And typically, if we identify in a DFD that these are one transaction and this is another transaction, so this data is processed through these functions, this data is processed through these functions, and these data are processed through these functions. Then there are three transactions here. We do a, in the structure chart representation, we have a root module or the transaction center module, and these three become the transactions here, T1, T2, T3. And then we again do a transaction analysis or a transform analysis on each of the transactions, and finally, we will get a module structure. We will see the details as we proceed. So, the main point here is that if we observe a DFD and see that it takes different data, we observe a DFD and find that different processes here take data, and these data are processed through different processes. Then we call this as the transactions, and this process maybe takes data here, produces output, maybe they share some data here, it produces data and this is shared and so on. So, we identify the transactions here and we write a transaction center module, and then we draw the 3 transactions, and these each transaction needs to be decomposed into further modules. For example, if we have this kind of a DFD, we see here that it takes many data items. For example, it takes one data item here, indent request, and it is processed here based on the pending order, and it produces an output, whereas a query is a data item which is processed through this and the output is produced, and the order is another item, data item, which is processed through these two and an output is produced. So, we will identify 3 transactions here. And once we identify the transaction, we will draw a transaction center module, and then the next level we will draw the 3 transactions. So, this is what the 3 transactions: root, handle order, handle indent, handle query, and then we factor them to get order, accept order and process order. So, we saw that the structure chart is obtained as a result of the structured design. We first do a structured analysis. Given a problem during the procedural design step, we will do a structured analysis where we look at the requirement specification, and then we develop the functional decomposition. We come up with the DFD model, typically consists of many levels, and then the next step we do the structured design. In the structured design, we take the DFD representation, and for each DFD we identify whether there is a we apply transform analysis or transaction analysis. Typically, very simple processing, that is the lowest level of the DFDs, they become transform analysis. So, if we have a DFD which is the level 1 DFD, and then we based on the level 1 DFD, for each of the bubble here in the level 1 DFD, we develop the level 2 DFD, and then the level 3 DFD if necessary, and so on. So, given a design like this, the context diagram we do not really use while applying the structured design. Start with the level 1 diagram, and unless it is a very simple system, like let us say the Tic-Tac-Toe or this compute RMS etcetera, very trivial software. Typically, the level 1 DFD, we observe that transform analysis needs to be performed. Only for very simple software, level 1 DFD will lead to a transform analysis, but typically a transaction analysis needs to be done for any non-trivial software, because a non-trivial software will provide different functionalities. Just observe that both compute RMS and the Tic-Tac-Toe, the user, there was only one user and could give only one type of move, but when there are multiple users, like let us say library software or any non-trivial software, we will see that there are multiple users and also each user can give different types of data to the system. For example, a user in a library software might issue a book or return a book or search for a book, and based on which functionality he invokes, different bubbles will get activated, and therefore, the level 1 DFD for any non-trivial software will normally be a transaction processing. So, we will have to apply transaction processing, and even the level 2 is often for non-trivial software a transaction processing, different transactions are possible here, and normally at the lowest level of the DFD, the transform analysis is applied, because those represent the simplest processing. And once the module structure is obtained, because through all these DFDs we will enhance the module structure, we will identify the root here and the transactions here, and then the processes that are identified here for transaction, we look at the corresponding DFDs and do the next level of the structure chart. And so on, and then we look at the next level. So, this we do the structure chart, the transform analysis for corresponding to the bubbles which map onto this, and so on, and until we reach the lowest level DFD, and there we will see that invariably the lowest level DFD is a transform analysis, where we have this typical read input, do some processing and produce output. We looked at the basics of procedural design, where starting with the requirement specification, we saw by taking the requirement specification, we identify the functions and draw the DFD model, and from the DFD model how to get the structure chart or high level design, and once we get the high level design, we do the detailed design by, for each module we develop the module specification in terms of the data structure and the algorithms. As the next topic we will take up is the object oriented design. The object oriented design is completely different than the procedural design, because we will see that the procedural design is a top down design. We start with the functions specified in the requirements document, split them, decompose them into sub functions and so on, and finally we get the structure chart representation. So, we start with the functions represented in the requirements document and then achieve the decomposition of that, and at the end of the data flow diagram we get a set of simple functions, and through a structured design we map this into a module structure. So, the procedural design is a top down design. On the other hand, we will see that in the object oriented design we have a bottom up design. In the object oriented design, we will first identify the objects, and then once we identify these are the objects, we will build the classes out of this, and then we will build the class relations between this in terms of aggregation, in terms of inheritance, and so on, and then we will do few other diagrams like structure chart and so on, and then we will get the code structure. So, we can say that the procedural design is a top down design, whereas the object oriented design is a bottom up design. So, the two design techniques appear to be entirely different. One is a procedural top down approach, the other is a bottom up approach, but then we will see that even during the object oriented design we will see that we will use the concepts of the procedural design, because after all for every class we will have methods, and those methods, some of the methods are in very complex method, and we need to design those using the ideas from procedural design.